With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, a clock with a metallic pendulum at 15 degrees Celsius runs faster by 5 seconds each day, right? And at 30 degrees Celsius it slows by 10 seconds. The coefficient of linear expansion is n into 10 to the power minus 6 per degree Celsius. Then find the value of n in nearest integer. So what will happen where, let's say the temperature at which the clock gives the correct time is this, right? The temperature at which correct timing is observed. So what will happen if you decrease the temperature? It will run faster. If you increase the temperature, it will run slower, right? Because we know that the time period of a pendulum, simple pendulum, is equals to this, right? So by increasing the length, the time period will increases and it will loses the time. And by decreasing the length, the time period will increases and it will gain the time, right? So basically, if you see the power of it, it is half, right? A power of length, if you put the constant here, then the length power is half, right? So we can write down that the change in by original time is equals to half of change in length, because the power is half, right? So if I see here the change in length by increasing or decreasing the temperature, let's say by decreasing the temperature, it will be original length alpha T naught minus the temperature T, right? Put it here. So it will be the delta T by T, it will be equals to half alpha T naught minus T, right? So if you see here, it is given that it gains temperature, like it runs 5 seconds faster at 15 and 10 seconds slower at 30. So I will write here like it is 5 seconds, it is gaining the time at temperature 15 degrees Celsius. So the temperature is less than T naught, right? So I will write it is alpha by 250, right? And it gained temperature, so it means that it is more than T naught, right? So I will write 30 minus T. Now you can divide the two to get the value of T naught, right? So further, after dividing, we'll get the T naught, and if you put that T naught in any of the two equations, you'll get the alpha, right? So if I divide the equation 1 by equation 2, it will be half. This 1 by t will get cancelled out. Alpha by t 2 also get cancelled out. I will write this by 30 minus T naught. So after solving, if you see, you got 30 minus T naught is equals to 30 minus T naught is equals to this, right? So from here I will write 3 T naught is equals to 60 and T naught is 20. Now you can put the T naught in any of this equation. Let us put the T naught in the equation first. In this equation, right? So if I put the value, so if I talk about the time for time period here, it is 24 hours into sec. If I convert it into second, it will be this, and it is equals to alpha by 2 T naught, that is 20 minus 15. So we'll get 5 by 2 alpha, right? 5 by 2 alpha. From here, you can write down, if you see here, this 5 will get cancelled out, and it will be, this 2 will also get cancelled out, and I will write 1 by 2 into this into this. right? This you will get after solving, and this is equals to 23 into 10 to the power minus 6. If you will solve it, then you will get this, right? And we wanted the value of n, right? Now if you see the value of n here, it will be 23. And this will be the answer of this question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.